Hello and welcome to this week's What Were They Thinking? This week's news items cover bizarre, dumb and weird. We start with the lawsuit over McDonald's chicken nuggets that led to burns in a child, the fact that COVID-19 vaccines reduce ICU admissions, police claiming they're being poisoned by fentanyl, that gay men are now allowed to donate blood in the USA, or at least the FDA has removed the restrictions, how eating later can change how your body metabolizes food. The Brussels sprouts taste so much different to how they were when previous generations ate them, and perhaps led to their current bad reputation. GMO corn and the rather demonstrable benefits it brings based on years of data. AI is trained to detect the early signs of Parkinson's. And finally, the discovery in an ancient Roman ruin. Timestamp for these and other news items can be found in the description box below. Let's start with the McDonald's lawsuit. A 4-year-old girl suffered second-degree burns from chicken nuggets, and McDonald's was sued, this being the inevitable outcome in America. It is somewhat similar to the hot coffee lawsuit of the 1990s. However, there are some important distinctions. The first is the hot coffee lawsuit was based on unusual market practices. That is, McDonald's was making their coffee exceptionally hot on the basis that people would travel away from the retail outlet and then consume it. In this case, chicken nuggets are expected to be consumed within a relatively short window of time of being purchased. That's what differentiates this case from the hot coffee case. The hot coffee case had a systemic and widespread practice that McDonald's knew about as they'd received prior complaints about it. In this case, McDonald's and the franchise owner was found guilty for 2 reasons. One, the franchise owner was liable because of negligence and failure to warn customers about the risk of hot food, and McDonald's USA for not providing safe instructions for handling of hot food. Unfortunately, this was a less than happy meal. In news that should be at least rather more promising, there is an immunotherapy for colorectal cancer. Rectal cancers of any kind tend to go unidentified for a very long time as people either ignore the signs or don't notice them. The most pronounced is going to be blood and stool, which can be dismissed by some people as simply being something like hemorrhoids or other issues related to a low-fiber diet. This then means that the cancers get quite pronounced before they're picked up, and they're very difficult to deal with. In most cases, in fact, they require surgery and, in a large percentage, are still fatal. With that in mind, a vaccine could solve a lot of these issues. The vaccine is built on the same technology as most recent vaccines have been, mRNA. Much like last week, where we spoke about a vaccine that used similar technology, this is the same again. It relies on a sample of the tumour. This tumour sample is then used to customize a vaccine, which is not a true vaccine in terms of what you might be familiar with. Say, for example, influenza. Rather, this does something similar but not the same. It's there to stimulate the immune system to attack the colorectal cancer cells. And because you've customized it to that individual, it's going to be able to attack that cancer and that cancer alone, as compared to other conventional treatments like chemotherapy that stop all cell division to an extent. In other positive vaccine news, we have data from Canada showing that those who have had COVID-19 vaccines have significantly lower risks of winding up in the ICU, and this is simply because they have better protection. Better protection means fewer serious symptoms or effects of COVID-19. This also has the carry-on result of fewer deaths. This is not just one result though, this is a part of a large body of research showing that you have much better outcomes if you have the COVID-19 vaccines, and although there is some variation in how much protection exists, overall the results are the same. If you had all of the vaccines as they've been provided in Canada, you had about 1/3 the risk of ending up in the ICU. Those who were unvaccinated, compared to those who had received the boosters as well, were more than 12 times more likely to end up in the ICU. Then there's the mortality argument. those who had been unvaccinated were 4 times more likely than those who had received the full range of normal vaccines, but they were also 15 times more likely than those who had received the full range plus the boosters that had come afterwards. Overall, the study is very compelling, and the results speak for themselves. Yeah, Canada is a particularly isolated country in terms of its oddities, as there are some quirks with regards to its similarities to America, but overall, you can infer a lot of the results from this elsewhere. Next we have the bizarre claim, or at least purported claim, that police say they're being poisoned by fentanyl. Fentanyl is a rather nasty drug. It doesn't take much to kill. However, the amount needed to kill and the amount you might breathe in is, well, to be quite blunt, not very well related. The reasons for this are fairly wide-ranging, but they relate to the fact that the amount you breathe in and actually gets to your lungs and then through the lungs into the bloodstream, or in other cases through your skin, is almost practically nil. And in fact, there aren't any records showing that police have actually been poisoned this way. And that's the big problem here. A lot of officers appear to be reacting to exposure, but reacting to exposure doesn't necessarily mean being poisoned. It could well be a sort of hysteric reaction. We say this as the most common symptoms described by police who believe they've been exposed to fentanyl include lightheadedness, palpitations, and nausea. All symptoms of anxiety. Going from a unfounded response to the inappropriate use of data, we have a debunking of the anti-vaxxers' use of VAERS. VAERS is the Vaccine Adverse Events Reporting System, and in short, it is a massive database of any and all possible reactions to a vaccine, whether related or not. For example, you might have a vaccine given to you, and on your way out of wherever you're given the vaccine, fall over and break your leg. Now, strictly speaking, that shouldn't be reported as an adverse event or reaction, but theoretically it could be. And that tells you how vague the guidelines are for reporting on this. It's why VAERS isn't a means of demonstrating anything. It is simply an indicator of possible events or reactions that should be monitored. For example, you might find that some people have a reaction in a certain area to a vaccine, and you might be able to trace back that the vaccine was somehow contaminated during production for a particular batch lot, based on that. That's the kind of thing you can do, where you can track down evidence over time, or specifically allocate it to one particular batch, but you can rarely make sweeping claims based on VAERS, and that's where this particular article is useful. The best explanation for VAERS is that it shows correlation but not causation. If you want to read through the article, you'll find the link in the description box below. It will tell you all about the fallacy of trying to use VAERS to demonstrate something more than it's capable of. For something completely different, we have the FDA lifting restrictions on gay men donating blood. Historically, homosexual males in America weren't allowed to donate. This is for a range of reasons. The biggest was simply that they were a much higher risk category for something like HIV or other sexually transmitted diseases. Understandably, this was a reason why they pretty much backed off and said no. Unfortunately, the laws weren't ever really revised after that came into effect. More so for the fact that, well, to be blunt, in many cases, the risks aren't as severe now. They are still there. Don't make that mistake. There is a higher risk category, but higher risk is not the same as having zero reason to allow them to donate. This is why the ban has been lifted. It's been in effect for about 40 years, and the medical knowledge, the ability to test blood, and the various other developments across the world have pretty much removed the stigma attached to homosexual males, and of course the donating of blood as a consequence. Ultimately, this decision should increase the availability of blood to some extent, but by no means is it going to be a silver bullet. This will not solve every problem. It simply means that more people are now able to donate. Next we have weird fungi news, but the development of an antidote to the world's deadliest fungi. It's a mushroom, and it's called the Amanita phalioides. Its name is otherwise known as the death cap mushroom, which should tell you a lot about it. Unfortunately, it's incredibly dangerous, because, well, it does look like other common mushrooms, and people, if they don't know what they're looking for, mistake it for the kind of edible mushroom that they're foraging. This then leads to them eating a deadly mushroom, and, well, deadly mushrooms cause death. Since this one mushroom is responsible for 90% of fatalities related to mushrooms, a treatment is ideal, and even better in this case, the treatment is a known and approved drug, although it's been approved for other purposes, specifically as a dye for medical diagnostic imaging. It's called indocyan green. In further food-related news, but this time when you eat rather than what you eat. If you are someone who eats much later in the day, this may be impacting your metabolism and particularly your body's increasing retention of weight. The study is a very small study, and we need to make this clear at the start. It only involved 16 participants, but they were all overweight or obese, and they were very closely monitored. This makes it a well-controlled study, but a very small study. Based on that alone, the study is able to make some pretty substantial claims that should be paid attention to, even if they aren't necessarily proven on a larger scale yet. The first is that the hormones in the body were disrupted by shifting around when you consumed food. Importantly, hormones that regulated whether or not you felt full or hungry were less pronounced the later you ate, meaning you had to eat more to feel full. The second is that the rate at which the body used calories was reduced if you ate later. This did have carry-on effects to adipose tissue, which is your fat. This had an increased stimulus to build up, and that meant that your body put on the extra weight to store it because it wasn't being used since your body burnt fewer calories. This created 3 different aspects from one study, and it demonstrated that not only was there a physiological aspect to it, but a molecular aspect to it. That is, how the cells responded and how the body responded to what was going on. Shifting back to new treatments, but also to fungi, there is an ever-growing interest in the use of magic mushrooms or psilocybin. This is also present in other drugs such as LSD, but the, let's say, natural source is magic mushrooms. It has increased interest as it does have a lot of neurological effects, and some of these do relate to not only the development of new neuronal connections, but also in neurotransmitters. In this case, the article from the conversation goes into a lot of its new applications, and how these new applications could be useful in various ways. The final bit of clinical news we have for you is not so much clinical directly, but related to it, and it's the Theranos scandal. Elizabeth Holmes has been yet again able to put off a prison sentence. Elizabeth Holmes was the CEO of Theranos, or at least former CEO, and she's well known for the controversy of her, well, scam. The entire idea of what she was selling is that you would have available to you a small blood test that could tell you much more than any other blood test or any other testing could do with the same volume or even same time frame. It turns out that the entire system that she was trying to sell to the world was made up, and that they were secretly running a whole battery of other tests in the background to be able to have their miracle device and miracle results show up the way they did. This led to her eventually being convicted, and this conviction carried with it an 11-year sentence. The representation she had has appealed the conviction and a range of other things, and this is why she's yet again been able to put off her prison sentence. As much sympathy as there is for somebody who had a child just before being sentenced, and one not that long ago, no, just because you are famous and, in this case, infamous, doesn't mean you keep to get putting off your sentence. At the same time, her representation is doing a very good job of playing the system's rules and giving her more time. in this case 21 days, to respond for the appeal. Next we look at Brussels sprouts, and the next few items overall relate to agriculture. Notably, why Brussels sprouts today aren't bitter. And this is something that, if you've spoken to older individuals, they may complain about their mother or father having cooked them as a child and them being rather terrible. Well, this may not actually be an issue to do with their parents' cooking. It may be that Brussels sprouts actually did taste bitter not that long ago, at least in relative terms. Through research in the 1990s, a Dutch scientist was able to figure out what was responsible for the bitter flavour, and then they could select seeds that had less of this bitter flavour present. From there, you're able to gradually get a more and more, let's say, palatable version of it available to people. By 2010, just about all seeds on the market were in this category of selected to have very few bitter compounds. In other agriculture-related news, we have a rather blunt summary of why organic will not work by the Genetic Literacy Project. It goes through debunking things like organic agriculture is pesticide-free, that organic agriculture can scale up to deliver a sustainable food supply, that organic food is pesticide-free, that it's less dangerous than genetically modified foods, and that it can feed the world. All of these are pointed out and very succinctly addressed as being unrealistic expectations of organic farming. The simple reality is that organic farming does use pesticides, that it isn't able to scale up and deliver a sustainable food supply without a huge increase in the land used for farming, that it does use pesticides, that it isn't any safer, and arguably is less safe than genetically modified food, and that organic farming can feed the world, again, without scaling up the available land being used. In similar news, we also have the fairly conclusive results from more than 20 years of data on GMO corn, and whether or not it increases crop yields, and is it sustainable. This is an important news item, not so much because it's anything amazing or new. In fact, it's pretty much what we've known for a very long time. That is, GMOs are safe, they do increase yield, and that they are healthy. The issue here is the data we have available. Data is the key arguing point for a lot of people. They say we simply don't know about the long-term safety of genetically modified foods. Well, we do, based on the fact that most food eaten throughout your life, the life of your ancestors, going back pretty much to the dawn of time, has been genetically modified, just with less specific and targeted means, so we know it's safe. But to satisfy the, let's say, overly concerned individuals, this data is available, and this data shows that over 20 years, it's safe, it works, and it does improve yields. In fact, it improved yields by 25%. Admittedly, that is on the high end. At the low end, it was over 5% increase in yield. What's worth noting is that there were reductions in what you could consider dangerous toxins, mycotoxins, fumonisin, and thricotesins. These not only lead to harm to humans, but also to animals. All of these were above 25%. The article goes into a great deal more detail on the benefits across the board, looking at different continents, and the short summary of what they found is that it does work and it is safe. Next we have disappointing news in the education field, and how a Texas A&M professor failed students thinking ChatGPT had written papers for them. The professional had used ChatGPT to find out whether or not their assignments had been written by ChatGPT, and it had claimed that yes, it did indeed write them. This is perhaps well outside their wheelhouse, given that they are a rodeo instructor and an agricultural teacher. Perhaps not the best person to be deciding whether or not ChatGPT is the authority on whether or not students have written papers. The bizarre thing is that ChatGPT is basically useless for this, but there are a wide range of tools available that could have done the job if used, which makes the decision to fail students and theoretically prevent them from graduating a very dumb idea. This whole situation could have been avoided by simply using appropriate tools, but the interesting thing is that the allegations alone led to several students admitting that they had indeed used ChatGPT for some of their earlier work, although it's unclear if they meant just the earlier work or earlier versions of this work. In further technological news, but going back to a clinical focus, we have an AI trained to recognize the signs of Parkinson's disease, but importantly, the signs of it well before you would detect it for clinical reasons, that is, symptoms or similar. The idea is that by taking things like brain scans or behavior, but notably blood samples, you can get a range of data. This data could theoretically be related to the earliest signs of Parkinson's, but on an individual basis, nobody's really able to figure it out. But if you can get enough data, you can gradually figure it out. And this is what they've done. They've taken blood from many individuals, and they've been able to run it through a machine, specifically a mass spectrometry machine, which breaks down the blood into its individual parts and then figures out what molecules are within it to within a reasonable margin of error. Depending on what molecules are found within it, they're able to figure out whether or not certain patterns of molecules, or that is certain clusters or groups of them, and certain quantities are indicative of Parkinson's, and the machine can then create a model based on that. The metabolites found basically indicate that there are certain molecules that will be associated with developing Parkinson's. Whether or not they are the sole factor, or if they are simply a result of early Parkinson's, or if they cause Parkinson's, is yet to be established. There is one other part to this we should point out. Although you'll see this heralded across various media as an AI, this isn't AI, this is machine learning, as it's unable to act independently of this single process. In further technological news, we have a wooden electrical transistor. Now, this may sound like a bizarre idea. The idea of using wood for transistors is, in some respects, dangerous. If you've ever seen a Lichtenberg device, you will understand why passing electrical current through wood is a terrible idea. But the Swedes, as always, like their wood, and in this case, the Linköping University from the KTH Royal Institute of Technology figured they're going to focus on wood. They didn't just use wood as it is though. The simple reality is that cellulose that makes up wood is terrible at trying to move a current. This is why it burns rather than passes current when you pass electricity through it, like the Lichtenberg device. Instead, they added an extra ingredient. This extra ingredient pretty much turned the wood into a series of channels, and each of those channels is what allowed the charge to pass through. This is useful, especially if you look at how much space there is between each of the molecules within wood, and this is why it's useful. Not so much because you're going to find it particularly beneficial in high technology, that's because it's really slow. It takes about 1 second to close the gate and about 5 seconds to reopen it when using it as a transistor. Technology that we're talking about when we talk about conventional transistors is in the gigahertz range. That is billions of times a second. So pretty much billions of times what this thing's capable of times 6. Then we also have the issue of size. These are very large devices by comparison to the kinds of chips you would find in a, computer chip, which has them on a tiny scale. So this is not only big, but slow. Finally, we have archaeological news and an ancient Roman ruin. In the ancient Roman ruin, they found a whole bunch of different medical waste material. The, let's say, dump site was made somewhere around the 16th century. We say made in that the materials were dumped there in the 16th century. However, the actual site itself comes from Julius Caesar's time, where he built a forum in Rome. And that's the site on which they found all of these remains. The current theory about the site is that it should shed some light on the infection control practices of this time, and how, if they were dealing with something potentially infectious, they would dispose of it here to try and stop it from spreading, like, for example, plague. What's more, unlike today, where material can be sent away to be incinerated if it's medical waste, this site was simply sealed as a once-off use. That is, they filled it with the waste and then they capped it with clay to never be accessed again or to let something like plague out. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.